All right, example 2, we're going to graph f of x equals 3 to the x. And so we got a table here. Let's start on the positive side. Let's start down at the bottom of it. So we know our x's, and we're going to plug them in. So when x is 1, we're looking at 3 to the first, which is 3. So that would give us the ordered pair 1, 3. So then we have 3 to the 0. What is 3 to the 0? Now remember the little thing we learned last semester, 0 exponent? The answer is? 1. There you go, 1. Okay? Anytime your exponent is 0, your answer is always going to be 1. So we end up with the ordered pair 0, 1. Then moving up, we got 3 to the negative 1. Well, what was that thing about negative exponent? What do we do? Send it to the bottom. Now we have a fraction. Remember that from last semester? You don't remember your exponent rules?
We're gonna send it.
All right, we'll talk about them in a minute. All right, so I'm going to send it to the bottom. Now we have a fraction, so 3 to the positive 1 goes on bottom. And I'm going to put just a 1 on top because I don't have anything in front of that 3 to the negative 1 to go there. And so that gives me 1/3. So I have the ordered pair, negative 1 and 1/3. And then moving up to the top there, we have 3 to the negative 2. Again, negative exponent, what do we do?
Send it to the bottom.
Send it to the bottom. So I have 3 to the positive 2 on bottom. What's going to go on top?
6.
A 1. And so we get 1 over, what's 3 squared? 9.
Wait, why is some number at 1? 6.
So we get the ordered pair, negative 2 and 1/9. All right, so now we got those ordered pairs. Can we graph them?
Yes, ma'am, you can.
All right, so now we're going to graph it. We got our graph set up here. So we're going to plot our ordered pairs. And negative 2 and 1/9. Where is 1/9 going to be at?
Right in between, like.
Just above the x-axis, right? Just barely above 0.
Barely.
So negative 2 and 1/9 we can say is there. Negative 1 and 1/3. Well, 1/3 is a little bigger, so it's going to be up a little bit more. 0, 1, and 1, 3. Now, what's going to happen as I draw to the left there? It's going to go down, but it's going to kind of flatten out. It's not actually going to cross that x-axis. What is that x-axis? Not axis of symmetry. Remember, that splits it in half.
Like from the last chapter?
From the last chapter. Horizontal asymptote. Very good. So exponential functions will always have a horizontal asymptote. And if they're a parent function, the horizontal asymptote's always going to be at y equals 0. And we ought to include that in our table. Because anytime we do a transformation, my horizontal asymptote will be affected if it affects my y's. All right, so let's go ahead and let's draw in our horizontal asymptote there so we don't forget later when we're looking back.
It's always going to be 0.
It's going to be at 0 for a parent function. Now, if my graph moved up, then my horizontal asymptote will move up with it, okay? My graph moves down, it's going to move down with it. Those are the only two things that will affect that horizontal asymptote. Because if it moves left or right, it's a horizontal line. If it moves left or right, it's still in the same spot. Okay, if it's a vertical stretch or shrink, it's going to stay in the same spot. I'm sorry, I said horizontal. I meant vertical stretch or shrink. It'll stay in the same spot. Same thing with horizontal, actually. So the only thing that's going to affect it is if I have a vertical shift up or down. But you'll see, as we're doing our transformations, we'll also go ahead and whatever we do to our y's, we're going to do to our horizontal asymptote as well because it's y equals.